carry on where we got to last time. So last time we just looked at this program here, which was our calcs program, and we were calculating and outputting the results that we needed, and we'd done the division and the remainder, and we'd actually formatted, I think I forgot to put the F on the end there, so to format it properly we should have a colon, then 0.2F, and when we do that and we run it, we will see that over here we get 4.33. So we've got two decimal places and we get 4.33. If I increase the number of decimal places, so I'll put that to 5 and run it again, this time we've got 5 3s. What's interesting, and a conversation we can possibly have, is if I make that something silly like 45 and run that, then you can see that we've got 3's repeating, and then all of a sudden it starts to go wrong, and that's quite interesting and something that people need to be aware of with computer programs and programming. And it's to do with the amount of storage that's allocated for variables and calculations. So we can see that it's quite accurate. I mean, we've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15 decimal places of accuracy there. And it's unusual for us to get or require more than 15 decimal places of accuracy. So that's what our float can give us. So our calculations from computers aren't always completely precise, as it were, or there's a limit to their precision, and you need to be aware of that when you're writing programs and use appropriate units and do the calculations. Okay, so if I just go back and put that right, so we're only going to have 2 decimal places, and we can be quite confident that at 2 decimal places our program is going to be precise in terms of the result it provides. Okay, so what I want to carry on with today is we're going to look at another calculation. So we'll close this file and we'll start a new file. Let's move that one over there. So we've got a completely new file to start, and this time we're going to do a calculation with speed, distance and time. So we're going to say speed equals, I don't know, say we're travelling at 30 miles an hour, and our distance is equal to 120 miles. How long is it going to take us to get there? So we could say time equals distance divided by speed, and then finally we can print out our time taken equals curly braces time, and I'll just put the F to say I want to use a format string, and now if we run that one, what's it going to give us? Oh, I need to save it, so we'll call this one speed 01 because I'm going to make some changes to it later. We'll save that, and if we run it, it says the time taken is 4.0. So that's correct. So if it was 30 miles an hour and it's 120 miles we've got to travel, it's going to take us 4 hours. Now, a couple of things that I might want to change with this program. I might want to put in different speeds. I might want to put in different distances. So rather than set the variables, we might want to instead get some input. But if I just put input, enter your average speed, if I try to run this, and I put in 30, I get a problem. And the problem is that it's worked out that later on in the program, when I want to divide by speed, I can't do that, because speed needs to be an integer or a float in order for me to do the calculation. Okay, so I've got this message that's appeared down here. It says in line 3, time equals distance divided by speed. And what it's worked out is when I've done the input for speed, I've actually input a string. Okay, now I can overcome that because I can use something called a cast. So I can say that I want either a float, or I could do the same with an integer. So now if I run the same program, type in 30, and it's working again. So if my average speed is 30, it will take me 4 hours. Just to, whoops, didn't want to do that just yet. So if I run it again and I say my average speed is 45, I now get my time taken as 2.6666 recurring. Okay, so I can input now and I can do that. The problem I still have, and we'll look at how we overcome this in a later program, but if I was to type for the average speed, if I put in, I don't know, 35 mph, then it says, whoa, wait a minute, you've asked me to input a string and then convert it to a floating point number, but what you've typed in isn't just numbers, you've typed in some text as well, and I don't know how to go about converting that to a number. Okay, so as I say, we'll have a look at how we'd overcome that problem in a later lesson, but for the time being we're just going to have to accept the fact that if we do set up to have a number input, then we're going to have to type in a number and behave ourselves as the user, and enter the value, the type of values that are expected. Like I say, in a few lessons time we'll look at how we overcome that issue and what we can do about it. So if we go back to our little problem here, we can enter our speed and we've got our time taken in hours. Now we've got two other things that we might want to do. First of all, we might want to vary the distance, so we can go back to our program, and we can actually change this in the same way. So we can have an input for our distance. So if we say we want to enter the distance, travelled, and again we're just going to read it in as a float. Now why I'm doing this, I'll just say that these prompts are important. So when you are thinking of designing programs and writing programs, it's important that you tell the user who's running the program exactly what they need to enter. Okay, so we could be a little bit more precise than this. We could say that we want the speed entered in miles per hour, and we want the distance travelled in miles. Okay, so we've said quite clearly what units we want them to enter these values in. This way, if they don't use those units and they get an answer which is wrong, then we've gone a long way to actually sort of showing why they've got a wrong answer. Okay, so our user does need to be aware of what they're doing. So we as programmers need to give them the appropriate prompts so they can actually fulfill that request for entry correctly. Okay, so now we'll just run this and make sure it works. So our mile, let's go a bit faster. We're going to go 50 miles an hour, and we're going to travel 135 miles. That's going to take us 2.7 hours. Now that's a little bit messy, because what's 0.7 of an hour? So we need to think about how we would go about correcting that. Right, so we had speed, distance, both input, and then we calculated the time it would take, and we had a small issue in that the time was a fraction of an hour, or was going to be an hour expressed as a fraction. But what we would really like is to have the time shown in hours and minutes, because that's what we would expect, and that's why it's easier to understand. The other thing I'm going to do now is also add in some comments to this code, which is something that we should be doing as we go along. So this code divides up quite nicely. So we've got two lines which are inputs, we've got a calculation which is just on one line, and we've got output which is on a single line. So the first thing I'm going to do is add a comment to the top, and that's going to be input, speed and distance. Now these comments may seem a bit trivial, particularly on a program which consists of only a few lines, but as we start to develop larger and larger programs, you'll see the benefit of doing that. So here we're going to have the calculations, and it's basically the calculations are for the time taken. And then finally we're going to have our outputs. Now, rather than having the time taken just as time, what we may want to do is say something like it will take approximately let's have hours, and minutes, oops, it's gone astray there, So it will take approximately so many hours and so many minutes. Okay, so now this time isn't going to be much use to us. So what we want is the hours. But if I do hours equals distance divided by speed, that's still going to give me our fractional value. Okay, I've got time equals distance divided by speed, so those two are the same at the moment. What I would like to do is find out exactly for hours exactly how many hours, and what I would like to do is to do a integer division. If I did an integer division, it would divide the two numbers and just give me the integer part of that calculation. And I can actually do that by doing that bit there. So that will give me the result, integer result of that division, even though I'm dividing two floating point numbers. So if for the time being I just put minutes equals 0, so we won't worry about minutes at the moment, and I just run this, my average speed, if I say 50 again, and I put 135 miles, it gives me 2 hours. Right. But just to be on the safe side, I can put integer here, and that will convert it, and it will also make sure that this variable hours is set to an integer, and that will be important to get a whole number output here. So for the time being, we'll just put minutes equals 0. We'll worry about calculating that in a second. I just need something to output into this string here. So if I run this, right, so I type in 50 and 135, I've got my 2 hours. So it will take approximately 2 hours, and I've got my 0 minutes because I haven't calculated my minutes yet. I've just put minutes equals 0. So how do I go about calculating the minutes? Well, I know how much time it will take, and time was a fraction, if you remember. So I can say time and then minus hours, so that will subtract the whole number. Okay, so if I've got time minus hours, that subtracts the whole number for me. If I then make sure that I've got an integer result going into here, or make sure that minutes is an integer. Okay, so what I've done there, I have got the fractional value. Sorry, my mouse is playing up a little bit. I've got a fractional value, and if I multiply that by 60, so the first calculation I do is find out the fractional part. So if you remember, I think it came to 0.7. So we had 2.7 if we just get our normal hours, number of hours, 2.7. So time minus hours, will say 2.7 minus 2, so it leaves us with the 0.7. If I multiply that by the 60, that will give me the number of minutes. And I want an integer value, so I don't want any fractional part of that, so I want the integer value of that, and then that goes into the variable called minutes. So if we just try that and we'll run it, so we've got our 50 and our 135, and we do get 2 hours and 42 minutes, because 0.7 times 60 gives us 42. So that's how we go about doing the calculation. So we've got our integer division, and then we've used that, so we've actually used the conversion from float to integer to do our time calculations. Okay, we'll finish off there for this lesson, and we'll look at selections next time. So again, we'll be repeating things about inputs, calculations and outputs, but this time, or next time rather, we'll be doing some selection statements and making some choices as we go through the program.